minutes at the most. Okay? Now, if you want to be successful on quizzes and tests in here, you will be organized to take notes. Some of you are terrible on organization. Try to be organized. Take notes. Usually not going to be a ton of notes. The first thing we want to take a look at is the idea of kinetic energy. Okay? That's what we want to look at, is kinetic energy. Now, you have had this probably since 7th grade science, right? What do we always know that? It's energy, what's happening? Energy in what? Motion. Anything moving has kinetic energy. So, it's energy in motion. So what's in motion? What types of things are in motion? Is air or wind a form of kinetic energy? What do you think? Yeah. It's molecules, air molecules in motion. How about water running? Yeah. River, build a dam, has to go from high potential energy to lower potential energy, turns turbines. We get hydroelectric. Okay. Do we have wind farms in Gage County? Yeah. Fairbury, Lancaster. There's a whole industry that is creating jobs, producing jobs. Those wind turbines, do you think they need any maintenance over a period of time? Yeah, they need lots of maintenance at times. Okay? And infrastructure to take the electricity that's being stored up and take it to somewhere where it can be used. So that's all kinetic energy. So we're going to look at kinetic energy in chemical compounds, or how they can be produced from chemical compounds. But I'm just going to go ahead and put matter. Because matter's in motion. In all those examples, matter's moving. The turbines, they're moving around. That's kinetic energy. Okay? So then we got this thing called potential energy. And ever since probably 7th grade, you learned potential energy is energy that is what? Stored up. You guys depend upon your phones so much that they run out of juice, and if you don't get them plugged in and juice back in them, you're going to die. I don't know if you're going to die or not, but you feel like you got to have that phone all the time. I'm glad that I don't have that inclination. I think a phone sometimes is more of a hindrance because I got to have it with me and answer it and all those things. So I'm not big on the phone. So you guys use it for social media big time. All right? But if you don't have those batteries, your phone don't work. Okay? And you guys some of you are coming in and plugging in the outlets in here, trying to get the juice, because by 8th period you're done. You have no more what? You don't have no more potential energy. It's all gone. Now you got to plug it in, and you got to store that energy up. And you got to try to do that as much as you can because you want to use your phones. So it is stored up energy. Ready to be used. A battery dead has no potential energy. Okay? There's no potential energy. So it's a good thing that, with technology, they have to find ways in which to make batteries better, longer lasting. Okay? Then we have this thing called chemical energy. Oh, chemical energy, your batteries are chemical energy. Now, what they do Is it 2 T's for battery, right? What am I doing, chemical battery? What am I doing? I'm thinking one thing and writing another. Okay? Chemical energy is a form of potential energy. It's stored up in a chemical. Okay? So when you take and plug in an electrical socket, electrical energy converts that battery back into a usable chemical energy that can be used up. Okay? That can be produced. So there's a connection between electrical and chemical called electrochemical energy. So, but chemical energy is just stored up energy in compounds. Okay, that's chemical energy, stored up energy in compounds. So that's stored up potential energy, really, in a compound. Okay, one thing you're going to do today, before you go, is you're going to do this reaction. And it's on that page. So this is a reaction you're going to do before you go today. You're going to measure how much potential energy you can convert into kinetic energy by heating water up. So what you're going to do is you're going to heat the water molecules up so they're moving faster. That's kinetic energy. Where does that come from? Chemical energy, which is a potential energy. So what you're going to do is you're going to take CH4 plus O2, and you're going to produce CO2 plus H2O. Okay? And that balanced equation would be like this. Right? If you remember, we did an energy diagram where we had potential energy here, and then down here we had time, and we started out on a level, then it went up, and then it came back down. And this is called a potential energy diagram. Okay? So, this is a potential energy diagram. Do you guys remember what we called this amount of energy was EA? You remember what we called this. When it had to get enough energy when it made the collision to get to the top and for the reaction to go. Remember what EA means? Okay. EA is activation energy. Does anybody remember what caused activation energy to lower, or could cause it to lower? Any ideas? This thing called a catalyst. You guys remember that? The catalyst, I'm not going to write it in, but it caused that hill to lower down. So I'm going to put here CH4 plus 2O2. They're going to collide. They're going to separate, and we're going to end up with 1 carbon, 4 hydrogens, and 4 oxygens. Down here are my products. So my products are CO2 plus 2H2O. Okay? Any questions? Okay, Brock, you getting this all down? Yep. Okay, good. So, what I need to do is show you what's happening, and then we'll let you guys do this reaction. Okay? You guys will do it, and you'll have a little time to spare if you need to work on some things to get some things in. It won't take you long to do the experiment, the first part of it. Okay? So here's, you guys tell me what structure this is. What is this shape? Without even looking at your sheet, what's the shape? Tetrahedral. Tetrahedral. CH4 plus. It's going to react with 2 oxygens. Okay. So we're going to have to break these bonds. So right here we have what's called bond breaking. Does it take energy to break the bonds? What do you think? Yes or no? Yes. Takes energy to break bonds. So energy in is endothermic. So this is what we call an endothermic process. Okay? Which means energy in. So you got to put a little bit of energy in before the reaction can take place. Alright? Now we boom, we do it. We form these products on this side. Does anybody know what this shape is here? I've drawn it correctly too. So, what is it? What do you think? Carbon dioxide, what kind of shape will it have? Linear. What do you think water? What kind of shape does water have? Bent. It's a bent shape. Okay? So this is bond making. So when bonds are made, do you get energy? Do you have to put energy in, or do you get energy out? What do you think? So the bonds come together, goes to lower potential energy. So what happens to that energy that's left over? It's converted into thermal energy. So it's exiting. So this is called an exothermic process. Okay, and energy out. If you get where energy out is greater than energy in, you get a exothermic reaction. Okay, and so many reactions produce thermal energy. And everybody knows thermal means what? What's another word for thermal? Heat. Okay? Produces heat energy. Okay. So any questions or comments? Takes energy to break bonds. We get energy out when bonds form. If the energy is greater on this side than this side, then we have thermal energy produced. And that's why your engine heats up. That's why your tailpipe heats up. That's why you can turn on the heater and there's warm air coming out after a little bit of time, hopefully. Okay, that's all deals with, we heat our house. Most of us, lots of us have furnaces in our homes. I have electric. My house is all electric. Everything. So I don't get a gas bill. A lot of you have gas, that you have a furnace in the basement or somewhere to where it produces thermal energy.